Hi everyone. In today's challenge, we're going to solve this problem. The problem name is minimum absolute difference in BST, means binary search tree, and the problem number is 530. Alright guys, so as usual, first of all, we are going to clearly understand this problem statement. After that, we are going to move to the logic part. We are going to see how we can solve this problem, what is the logic to solve this problem. And after that, we are going to move to the implementation part. We are going to implement our logic in C++, Java, and Python programming language. Fine guys, now let's understand this problem statement. So problem say, given the root of a binary search tree, means BST, return the minimum absolute difference between the values of any two different node in the tree. So guys, simple thing, the first thing is what is given? Given is the root of a binary search tree. Right, if you consider this example one, so we are given nothing but 4, right? Alright, and second thing what we have to return? We have to return nothing but we can say the minimum absolute difference between any two node in this binary search tree. I hope you are getting it right. So here let's understand this problem with this example 1 and example 2. So guys, in example 1 you can see that we are given nothing but this binary search tree, right? Here if you will see that minimum difference we can get between 2 and 1, right? This is going to give us nothing but 1, right? And this is also going to give us 1. So we can say minimum absolute difference in nothing but we could say 1, right? So we can't get less than this particular 1. So we are going to return nothing but answer is 1, right? And in the example 2 also, if we will focus over here, so we have this binary search tree, right? So the first of all, we are getting this minimum difference here is 1. 1 minus 0 is 1, right? And rest we are getting here also 1. Here is not a 1. Here is a more than 1. That means nothing but 36. And here also more than 1. That is 47. But the minimum difference we are getting nothing but 1 only, right? So we are going to return answer nothing but 1 also in this case. So you can see also output is 1, right? So guys, simple question, simple understanding. So let me just summarize this. We are given first of all a binary search tree. After that, we have to just find a such node that the minimum difference between that these two nodes should be the minimum. So we have to return that minimum difference, right? We don't have to return that node value as well. We just need to return the minimum difference we can get from any two nodes in this binary search tree. So I hope guys now you understood the problem statement. So now let's move to the logic part, see how we can solve this problem, right? And as this is the easy problem, so you can't expect the much more logic or much more difficult algorithm in this problem. So let's move to the logic part, right? Here logic. Fine. Now guys, how we can solve this problem? See guys, for finding the minimum, one thing what you can do like for the first brute force approach, it could be just traverse over this binary search tree, store in a array, and then you can like we can say you can find out any two nodes such that the minimum difference is 1, right? So if you will traverse over this binary tree, you will get like this 4 2 6 1 3. Now you can keep you can say use a for loop, traverse over this array. Now for each value traverse over the another array. So what I mean guys, let's say we have this value, right? So this is the brute force approach. It's not gonna helpful, but let's see, this is the brute force approach, right? So we have taken this array from this binary search tree, stored in our array. Now what we are doing, we are saying that first of all for I till the n traverse, and inside that also for j till the n traverse. Now if I and j are not equal, then calculate the difference between this I and j value. And once you calculate the difference, store in your result variable and keep try to minimize that one. And once this loop over, you can return that particular result variable, right? Simple thing. You can find the minimum two, we can say the minimum difference between two variables or between two numbers from this array, right? So this is the brute force approach, which is going to take big of n time as well, right? Most, so not big of n, big of n space and big of n close n time. N space is to store the numbers in the array, and n close n is nothing but we can say to traverse over this array to find the minimum, right? So this is the basically the brute force, we can say the scope, right, time and space complexity. But how we can we can say optimize this particular problem, right? So for this, let's move to the we can say better approach than brute force. So better approach. So here guys, what we can do, so here we can say guys, if we will focus over, this is a binary search tree, right? And you must know what three we can say traversal. No, I don't expect more than three, but at least you should know three, right? That is nothing what we could say pre-order, in order, and post order, right? If you know this, if you know tree, then you must know this traversal, right? You must have traversed your tree like using these three order, right? Pre-order traversal, in order traversal, and post order traversal, right? So can you just tell me, if a tree is not a binary tree, it is a binary search tree, then in order traversal is going to give you answer in what way? In order answer is going to give you answer in sorted order. Always remember, if you have a binary search tree and you are doing an in order traversal over that tree, so that will also going to give you an answer, we can say, or in sorted order. So let's try to do a in order traversal on this. So if you will see here, so here you can see we have one, right? Not one, you can say this is the root, right? So we are going to come to root. In order says that I follow the approach. First of all, I go to left side, then root side, then right side. This is in order C, right? So now guys, let's see. First of all, it's gonna go to the left side, means come to 2. This is also gonna to the left side. This is 1, so we are gonna write 1, right? After that, now it's gonna come to the root. So one root is 2, so it's gonna come to 2. Now it's gonna move to the right. 2 right is 3. Now this 3, this whole part is completed, right? This whole part is completed. This is nothing but left of 4, right? So it's gonna come to the root, that is 4. Now 4 is gonna to the right, that is 6. So you can see guys, 1 2 3 4 6 means a sorted order, right? So in order traversal always gonna give you answer in a sorted order. So did you find any way that what we can do? Right? You go to the idea. So what we are gonna do is nothing but we are gonna store this in a array. 1, 2, 3, 4, and 6. Now we can just traverse over n times, means we can just use a one for loop and we can find the minimum difference between n two variable, right? But this is also going to give us space, right? This is also going to take a space, which is big of n space complexity, right? Although the time complexity is going to be nothing but we can say n only, but space is also getting consumed in this particular approach. So we are not going to use that approach as well. But I hope guys you understood that you can, if you will do this thing, your solution will also get accepted, right? If you're going to store in an array. But why do we need to store in an array? Just tell me this. We just need to find a value, right? So the best approach is gonna be nothing but we can say the optimized one is don't use array as we can say array as well. Just what you have to do, you have to traverse over this because in order to traversal on this particular we can say tree and keep finding the minimum we can say minimum difference between two value. So let's understand this or go through this particular thing. So now you will get a better idea. So guys, what I'm saying that first of all you will be here root, right? Now after that you will be going to 2, right? Then also you will go into 1, isn't it, right? So once you are at 1, fine, it is the first node your in order to ourselves will be getting. So you don't gonna do you will not gonna do anything, right? You will say fine, I have 1 stored in my previous variable. Previous is gonna have nothing but 1. Now this is gonna come to now 2, right? So on 2 I will check if previous is not equal to -1. Earlier it was 1. If previous have some value, yes, previous have 1. So now calculate the common difference, or I can say the difference between 2 and 1, which is nothing but 1. So I can say result is nothing but we could say 1, right? Now this 2 is going to come to 3 and previous is going to be nothing but equal to 2. So 2 come to 3 here we have now, and 3 will say is previous have some value, right? Previous has value 2. So now calculate the difference between 2 and 3, which is nothing but 1. So we are going to not update our result because it is already less than or equal to that 1, right? Now this 3 is going to come to this 4. Now we have here our we can say our traversal is here now, and previous is now 3, right? So it's going to say is previous have some value, right? Previous has a 3, so we are going to calculate the difference, which is going to be nothing but 1 again. So we are not going to update our result. Now it's going to come to the right here. Now is 3 and the previous value is nothing but 4, because we have all previously seen we can say check with the 4. So now it's going to say is there something value in previous variable, right? Previous has some value which is 4. So we are going to calculate the difference. 4 minus 6 is nothing but 2, and so we can say result is now, we are not going to update our result because the value we are getting is greater than is the result, right? So we are not going to update it. So we're going to say okay, move ahead. And if you see there is no more node left, right? So our in order to ourselves is going to complete, right? Once our in order to ourselves completed, we are going to see that our result is going to have the minimum difference between two variables. So I hope guys you could understood now, right? I hope now you understood the logic also. What we are going to do actually, we are going to just use a node to ourselves, and after that we are going to return our result. So I hope guys we have seen our three approaches. First is brute force, where we were storing our first of all in our array. After that you can you may sort it and you can find the minimum difference, but that's going to take big of n cross n time complexity if you're not sorting it. If sorting, then also it's going to take log of n. This is the brute force approach. Then better optimized approach is that use a node traversal only but stored in an array, and then you can find a minimum we can say difference, right? So that is going to take a better approach is going to take a big of n time complexity but big of n space also, right? And the best approach is big of n time complexity but not a big of n space. It is only going to take big of one space. So now guys, let's move to the we can say the implementation part and implement our logic in C++, Java and Python programming language. So I'm guys with the Python. First of all, what I'm going to do, I'm going to say define two variables. First of all, result and previous. Result is going to be nothing but maximum 1. So you can say float infinity, and previous is going to be -1. Why is it so? Because you must always see that we can say constraint here, right? So they have told us that node value will never be greater than never be less than 0, right? It will always be greater than or equal to 0. So we can assign previous is equal to -1 so that we can check if previous is -1, that means we haven't traversed, we haven't got any previous node, right? So we are going to use here a function which is nothing but in order, and here we're going to take a root, and we can say if root is null, if not root, so you can directly return, right? If it is there is a root, so first of all go to left side, then go to right side, and here guys in between we are going to do our task, right? So what we are going to do here, we are going to say first of all, if previous is not equal to -1, that means we haven't we have already find a previous node, right? Then check it, result should be equal to minimum of result comma absolute of result or not result root dot val minus previous. This is what we actually doing, right? After that assign this root value to previous, so we can say this one, right? After that you are gonna call this function in order this root, and you can return your result, right? But there is one issue, guys. We don't know what is the result because we are using inside this function, and this is a local variable, not a global variable, right? Which means it is not and not also class variable. So what we can do, we can use a non-local keyword result and previous, which tell us that we are going to use this result and previous variable inside this function. Now let's try to run this code and see whether it's working fine or not. And you guys can see that both the tests pass, right? So let's try to submit this code as well. And it's taking a time, right? And here we go, guys, right? So it's successfully submitted with Python. Now let's move to the next programming language, that is nothing but we could say C++, right? So here, guys, first of all, what I'm going to do, I'm going to say result, and which is going to be nothing but equal to maximum 1. So we can say like 4 and 5, this is the maximum, because the we have seen in the constraint that the value is not gonna more than 10 raised to 5, right? So we have assigned 10 raised to 5 plus 1, and previous is going to be nothing but minus equal to 1. We have already seen the reason of this, right? In order, we are going to call this function root result and previous, and after that we are going to return our result, right? So here we are going to define a one function. Let's say here the void which is not going to return anything, and after that we are going to say in order, and here we are going to first of all tree node, let me write node, and here we are going to say int result. See guys, I'm using a pass by reference, right? And here also in previous. Once this is done, what we are going to do, we are going to say if root is null ptr, that means root does not exist, right? So we can say return, right? If it is exist, so call this in order root for left, and result is going to same, previous is also going to same. After that in order for right result and previous. In between of these we are going to use our logic, because first of all we want to traverse left, then want to find a difference, then want to move to the right side, right? So here we can say if previous is not equal to -1, then you can say result should be equal to minimum of result comma absolute of result root, not result, root of value and minus previous, right? Once this is done, you're going to say return, not return, you're going to say previous should be equal to now root dot root value, right? So now once we are going to done this, we are going to call this we can say run this test cases. Let's see whether it's passing all the test case or not. So you can see guys, both the test case pass, right? So let's try to submit this code as well. And I hope guys you are getting this right. If you have any kind of doubt, you can write in the comment section, right? Now let's move to the last programming language, which in nothing but we could say Java. And here guys in Java, first of all we are going to define two global variable, which is nothing but int result, which is going to be equal to 1, 4 and 5, and we can say previous, right, which is equal to -1. And the reason why I am declaring in global, because in Java function we can't pass this value as a pass by reference, right? We have to either use a list or we can say array list, right? So we are going to define one function. Before that, let me just say here call this function in order. The function is going to accept root only, and here we can say return our result, right? So guys, what it gonna do, it's gonna first of all I define this function, right? Public void in order, and here we can say tree node, we can say root, right? And nothing else, just this only. So we are going to say nothing but here we can say if root is null, so you can say simply return, right? Because root does not exist. If it is exit, so you can say call in order for root left, call in order for root right, and in between that you have to just calculate your difference, right? So if previous is not equal to -1, so what you can say that find out the minimum difference, result is going to be minimum of result and absolute of, see guys, we don't have absolute and minimum, also we have to use from math keyword, math or not keyword, math library. So math dot minimum, math dot absolute, and here we are going to pass root dot value minus previous, right? I hope you are getting these things. If you are not getting, I'm again saying, if you are not getting this particular part, you can write in the comment section, because I will come to know that in future videos I should explain in the more detail, right? Here I'm expecting that you must know the basic at least of programming language, right? Now we are going to say previous should be equal to root dot value. Let's try to run this code and see whether it's working fine or no. And here you can see that we got an error because we haven't used a value, right? We have used a val only. Alright guys, so now let's see. And here is also you can see that both the test case passed. So let's try to submit this code as well, right? And I hope guys it will also get submitted, right? And here we go guys, right? So we have successfully submitted with Java as well. So guys, we have successfully submitted with C++, Java and Python programming language. And we also understood the logic part with 3 different approaches, and we have also understood the problem statement. So if you have any kind of doubt in any of these 3 sections, you can write in a comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet in the next video.